Welcome to qnawire.
All right, question 65 in the book states that you accidentally drop an eraser out of the window of an apartment 15 meters above the ground. Part A states how long will it take for the eraser to reach the ground? Okay, we'll go part by part here. But let's see. So part A asks how long, so we're looking for the time it takes for this eraser to hit. Right? So if we look at it again, our kinematic equations, the one that best describes what we're dealing with and what we're looking at is the equation of D equals, I guess I use H here, so maybe I'll use H just because it's the height of a building, although D is appropriate if you wanted to use that as well. V naught T plus 1/2 AT squared. So it's important to remember when we're dealing with gravity questions that have to deal with, thinking about two directions, up or down. If we define a specific direction to be positive or negative, down or up, it does not matter which you choose. But what will matter is as long as you maintain the proper sign of your equation, either positive or negative, that's what really matters. So for this one, I'm going to say my positive direction is downward, such that the height that the item will fall, the eraser will travel in the positive direction, as well as the acceleration due to gravity g is also positive, because again, that's the direction of motion that I choose. So in this scenario, although it doesn't say, we can assume that it starts initially at rest. So we have an expression for time which we can solve for, such that time is 2 times the height of the building over g. Obviously g is our acceleration here, and that is square rooted. And by plugging in our values, 2 times 15 meters over g, 9.8, that whole term square rooted, we find that the time traveled to fall down to 2 significant digits, simply 1.7 seconds, not meters, that wouldn't make sense, 1.7 seconds. Great, part B will do above. It asks, what speed will it have just before it reaches the ground? Well, we can use the kinematic equation of V equals V naught plus AT. Again, if we assume it starts at rest, again here every term is positive, velocity is downward, acceleration due to gravity is downward. So we have simply 9.8 meters per second squared times 1.7. I'm going to put 5 here because as an intermediate calculation, we want to use more digits. And by doing so, we find that the velocity to 2 meters per second, 2 significant digits, is 17 meters per second. Great. Part C, if you multiply the same interval from A and the speed from answer of B, why is the result much more than 15 meters? So they're saying if it takes 1.7 seconds to fall, and the maximum speed is 17 meters per second. Well, first of all, let's look at that product. It's saying why is that larger than the height? So we're saying this distance here is 1.7 times 17, which if we calculate in 1 second, if I run the numbers, 1.7 times 17 results in 29 meters. That's 28.9 meters, but 29 meters to 2 significant digits. Well, of course, this is inaccurate because the answer that we found in part B was the maximum speed. So if you think as the eraser gets dropped, it starts off initial speed of 0. And if we were to use a motion diagram, obviously we represent this falling with higher and higher, or larger and larger vectors that would represent a maximum velocity as it hits the ground to be 17 meters per second. So it would be inaccurate to consider this whole path to occur at 17 meters per second. So that's why this answer for part C is larger than 15 meters.